Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at the quadratic function and how we graph it. A quadratic function is defined as y equals ax squared plus bx plus c in general form. And if we were asked to graph this, the graph would be in the shape of a parabola. And there's some interesting characteristics about that parabola that I want to discuss. When you have a parabola, you'll have a minimum point, which we do in this case, or a maximum point. So if my parabola opened down, I would have a maximum point, and that minimum or maximum point would be called the vertex. And the line, the vertical line through that vertex, so in this case here, I drew y equals x squared. The vertical line, which is the y-axis, that goes through the vertex of this parabola will be the axis of symmetry. A parabola will be a mirror image of itself on each side. So if I were to put a mirror here, this shape on this side would be identical to that. So there is an axis of symmetry for a parabola. So when you're asked to graph a quadratic function, you usually would start with finding the vertex, and I'm going to show you how that's done. Then we know there's an axis of symmetry through that vertex. Some other really helpful information in graphing that is the y-intercept. And then we find x-intercepts if there are any. So let's take a look at a few examples to demonstrate this. In our first example, we have y equals x squared minus 4x. We do have a formula that tells us how to find the x coordinate of our vertex. X is equal to negative b over 2a. The sign of a tells us whether the parabola opens up or opens down. If this is positive, the parabola opens up. If it's negative, it opens down. So just additional information to be aware of when graphing quadratic functions. So I'm going to start off with the vertex. So I know the x coordinate of the vertex will be negative b over 2a. So a positive 4 over 2 is 2. When we're finding points, which a vertex is a point, we need the two coordinates. I have the x. In order to find the y, I plug into my function. There's the definition of y. So y will be equal to 2 squared minus 4 times 2. 4 minus 8 is negative 4. So I know my vertex is the point 2, negative 4. My next step would be to find the y-intercept. The y-intercept is the y value when x is equal to 0. So it's very easy to find because you have y isolated. So the y-intercept in this case will be 0 squared minus 4 times 0, which is 0. So my y-intercept will be the point 0, 0. The next thing I would do is find x-intercepts. You may or may not have x-intercepts. You may have 2, you may have 1, or you may have none. When you're finding x-intercepts, that's the x value when y is equal to 0. So if we make y equal to 0, what we end up with is a quadratic equation. We talked about solving quadratic equations in the previous videos. So we can use the quadratic formula, we can use factoring. I'm going to factor because that's going to be the least amount of work and the easiest. So I'm going to factor an x out of both terms. So now that it's equal to 0, I know that either x equals 0 or x minus 4 is equal to 0, in which case x is equal to 4. I already knew this one because it's the same as my y-intercept. So the two x-intercepts that I have will be 0, 0 and 4, 0. So I have my vertex, my y-intercept, my x-intercepts. That gives me quite a bit of information. I can get a fairly good idea of what this graph looks like. So the vertex is the point 2, -4. It's going to be my minimum point because I know, because this is positive, my parabola opens up. I also know that I have an axis of symmetry through the vertical line x equals 2. I have a y-intercept of 0, 0, which also is in my x-intercept. And I have a x-intercept of 4, 0. So now that you've got those points, you have a fairly good idea of what your graph is going to look like. It's not perfect. I don't have the symmetry that I'd like to have, but I hope you get the idea. Let's try another example. In our second example, we notice that we have a negative coefficient for our x squared term, so that tells us right away that our parabola is concave or opens down, and that means that the vertex will be a maximum point of our graph. So we're going to start off by finding the vertex. And we can do that by using this little formula. So x will equal -b, b is 2, over 2 times a is -1. When I simplify -2 over -2, I get a 1. We have to find the corresponding y value for our vertex. So we do that by plugging into our function. So it will be -1 squared plus 2 times 1 plus 3. Be careful you don't include that negative in the power. The only thing that's squared is the x. The negative is a coefficient outside of that. So the y value would be -1 plus 2 plus 3, which would be 4. So the vertex is the point 1, 4. Next step, find the y-intercept. It's the y value when x is 0. So it'll be -0 squared plus 2 times 0 plus 3. So the y-intercept would be the y value when x is 0. So x is 0, y is 3. Next step, let's find our x-intercepts. That's the x value when y is equal to 0. So we make y equal to 0. Now that it's equal to 0 and I'm solving, whatever method I use, whether it's factoring or quadratic formula or completing the square, I don't really like having a negative coefficient for my x squared term. I don't care about the coefficients for the other terms. So what I need to do is get rid of that. I can't, when it's in function form, I can't multiply by anything because that changes the function. But I made it equal to 0, so now this is an equation. I can multiply both sides by -1. So I'll get 0 equals x squared minus 2x minus 3. And that's going to be easier to solve whatever method you're using. I'm going to factor this. This is factorable. So it will be x minus 3 times x plus 1. But you could use the quadratic formula if you prefer. And so when I've got two products equal to 0, I know that either this factor is equal to 0, or I'll get a solution if this factor is equal to 0. Remember that factor theorem only works when this is a 0. Any other numbers, this doesn't work anymore. But 0 it does, so I get a solution if x equals 3 or if x equals -1. So there's my two x-intercepts, 3, 0, and -1, 0. So with that information, I'll now draw a graph. All right, so my graph is I'm going to plot these points best I can without graph paper. So there's the vertex, 1, 4. We have a y-intercept at 0, 3. So that's where it crosses the y-axis. We have an x-intercept at -1, 0 and at 3, 0. So this time I have 4 points to work with, and now I'm going to try to draw my parabola using those points. And that gives us a fairly good idea of what that quadratic function will look like. Let's do one more example. In our last example, we have y equals negative 2x squared minus 2x minus 6. We know that the parabola will open down and it will have a maximum point at the vertex. So let's find what the vertex is. Let's find the x coordinate first. So it will be negative 2 over 2 times a, which is negative 2. So that's going to be 2 over negative 4, which is negative 1/2. Now that I have the x coordinate, I can find the y coordinate. I plug the x value into the function. Negative 1/2 squared would be positive 1/4. Negative times a negative is positive. 2 times 1/2 is 1. Multiplied, that gives me negative 1/2. Plus 1 minus 6 gives me negative 5. I want a common denominator to combine these. So I'm going to change 5 to 10 halves. Which is a negative 11 over 2. So that is the vertex, negative 1/2 and negative 11, 2. Next, I'm going to find the y-intercept. So when finding the y-intercept, I just put a 0 in for x. So it's going to be 0 minus 6, 0, negative 6 is the y-intercept. Now I'm going to find x-intercepts. That's the x value when y is equal to 0. So we set y equal to 0. And we solve. Now that it's equal to 0, I don't have to keep that negative coefficient. I can't change it when it's a function, but when I make it equal to a specific value and I'm trying to solve that equation, I can do it to an equation. I just can't do it to the function. So I'm going to multiply everything, both sides, by negative 1. So I'll get 0 equals 2x squared plus 2x plus 6. Next, I'm going to factor out a 2. When you have a constant times something equal to 0, that constant can't equal 0. So I'm just going to divide through by it. So my equation will be x squared plus x plus 3 equals 0. Now let's solve this. It's not factorable, so let's use the quadratic formula. It's going to be equal to negative b, so negative 1, plus or minus square root of b squared, so 1 squared, minus 4 times a, which is 1, times c, which is 3, all over 2 times 1, 2 times a. 1 minus 12 is negative 11. That's an imaginary number. The square root of a negative number is imaginary, so we have no real solutions to this equation. Therefore, there's no x-intercepts. This parabola is not going to cross the x-axis. So let's try drawing this. So when I plot my vertex, it's going to be negative 1/2 and negative 11/2. So the vertex is going to be approximately right there. The y-intercept is 6, that's where it crosses, or negative 6, that's where it crosses the y-axis. And we don't have any x-intercepts. I know it's concave down, so it's not going to cross this axis. It's just going to look something like that. All right, that's how we graph quadratic functions. Practice these, just go through those steps, find the vertex, both the x and the y coordinate, find the y-intercept, and then find if there's any x-intercepts. That concludes this video. Take care, and we'll see you on the next one.